going to have a look at some symmetry properties of circular functions today. If we're given some information like sine theta equals 0.52, we know that that's talking about the first quadrant. But if we extend that angle and look at its symmetry angles in the second, third and fourth quadrants, we can find the sine, cos and tan of various angles without picking up a calculator. It's very useful to us. So if we're looking for sine of pi minus theta, we know that this is pi here, so pi minus theta puts us in the second quadrant where sine is positive, so we can write our answer as 0.52. If we're looking for sine of pi plus theta, that puts us in the third quadrant. We know that sine is negative, so that's negative 0.52. And 2 pi plus theta puts us back in the first quadrant, so that's 0.52. If we're given cos x equals 0.68, we can use the same technique. So pi plus x puts us in the third quadrant where we know that cos is negative, so it's negative 0.68. 2 pi minus x, fourth quadrant where we're positive for cos, 0.68. And pi minus x is the second quadrant, so we know that that's a negative one. Tan is positive in the first and third quadrants, so pi plus alpha is positive because it's the third quadrant, so 0.4, whereas 2 pi minus alpha is in the fourth quadrant where we know tan is negative. 2 pi plus alpha back in the first quadrant, so we're positive. Let's have a look at 6D, which covers negative angles as well as complementary angles. Let's start with the negative angles. They're not very interesting. If we know that this is theta, and we look in the fourth quadrant where it's negative, we know that sine is negative in the fourth quadrant, so sine of negative theta is going to be the same as the negative of sine theta. Cos is positive in the fourth quadrant, so it's going to be positive, and tan is negative, therefore it will be the negative of its first quadrant angle. Let's look at the complementary angles because they're a bit more interesting. If we look at this right angle triangle here, say for example that is pi on 6, we know that this angle up here must be pi on 3 because they are complementary. They need to add to pi on 2 or 90 degrees. So we know from our table of exact values that the sine of pi on 6 is equal to a half, and the cos of pi on 3 is also equal to a half. And if we were to pick up our calculator and try any complementary angles, we would expect that that would say that it was true. So sine of 20 degrees, we expect that it would say that it is equal to the cos of 70 degrees. And we can do that for any complementary angles. So if we have a look at our calculator, there I've done a couple for you, and you can see that the calculator is verifying that it is true, that the sine of an angle is equal to the cosine of its complement. It's very important that you remember that. So let's have a look at some examples now. We've got a question here, if sine x equals 0.3, cos alpha and tan theta. So let's have a look at the negative ones first. We know that cosine of negative alpha, that's putting us in the fourth quadrant where cos is positive, so it's going to be the same as the cos of alpha. So there it is, 0.6. Sine of negative x, we know sine is negative in the fourth quadrant, so it's going to be the negative of sine x, or negative 0.3. And similarly, tan is negative, so it is going to give us a negative result. For the complementary angles, when we look at cos of pi on 2 minus x, pi on 2 minus x, we're in the first quadrant here, so we know that cos of an angle is equal to the sine of its complement. So that means that cos of pi on 2 minus x is equal to the sine of x. So that equals the sine of x, which we know is 0.3. And the sine of pi on 2 minus alpha is going to be equal to its complement. So alpha and pi on 2 minus alpha are complementary. Therefore, the sine of pi on 2 minus alpha is going to equal cos of alpha which we've been told is 0.6. We've got to be a little bit careful with the next one because now we're going into the second quadrant. The angles are still complementary, but we have to remember the sign. So we know that sine of pi on 2 plus alpha, its complementary angle is cos of alpha, and sine is positive in the second quadrant, so it's going to equal cos of alpha, so it's still 0.6. However, when we do the cosine of pi on 2 plus x, once we go into the second quadrant, we have to remember that cos is negative, so it's going to be minus the sine of its complementary angle. So in this case, we end up with a result of minus 0.3. And we can do this also in the third and fourth quadrants. So 3 pi on 2 minus alpha puts us into the third quadrant where we know sine and cos are both negative. So it's going to be minus the cosine of the complement, which is minus 0.6. And finally, sine of 3 pi on 2 plus alpha, plus, it should be an alpha, puts us in the fourth quadrant where sine is negative, so it's going to be the minus of cos alpha, which is also minus 0.6. This tan one's a bit interesting. I think a really easy way to handle a question like this is, well, first of all, which quadrant are we in? Pi on 2 minus theta puts us in the first quadrant. So we can just use a simple triangle to help us out with that one. I'm just going to draw a right angle triangle. I don't know how that's going to go. Not so good. Try it again. Okay, not too bad. Alright, so we know that tan of theta is 0.7. If we think about tan of theta in fraction form, that's 7 on 10. So if this is theta here, theta is opposite over adjacent. So there we go, we've got 7 over 10. Now if we're looking for tan of pi on 2 minus theta, we're looking for the tan of this complementary angle up here. So using this angle at the top of the triangle, tan of that is going to be opposite over adjacent, so it will be 10 on 7. So tan of the complementary angle equals 10 on 7. So that's a really nice, easy way using triangles to solve that one. You can do it algebraically, but that's a really easy one to use your triangle to do.